All right, welcome back. This is our first lesson on simplifying polynomial expressions, and this is what you thought algebra was coming into this class. For the first 6 weeks of this class, we have been all over the place. We've been way over here doing sequences and series, and then we're out on Mars doing pure permutation and combination. Then we're jumping way over here and doing normal distribution, and nothing that you've learned seems to be related. But you've been traveling up this steep slope of trying to understand what's happening, and it's been difficult to walk uphill. Okay, but you finally arrived, and now we're walking on what? Flat ground. In fact, I should try that flat. Okay, flat ground. So everything, I guess I should say it like this, the course gets easier. If you keep up with your homework, it's everything that we learn today will be directly related to what we learn tomorrow, will be directly related to what we learn the next day. Everything falls in order. And in fact, things seem to make sense now. Things are going to start coming together. And believe it or not, everything you've learned in this class, excluding normal distribution, is all going to culminate into one lesson. One lesson. And in that one lesson, everything that you've learned all year will be in that one lesson, or at least concepts from everything that you've learned is going to be in one lesson coming up in about 4 weeks. And you say, how is permutation combination related to absolute value equations? Okay, everything comes together into one lesson. It's very, very interesting. But I want you guys to understand this. Right now, things do seem to get a little easier, but if you do not keep up with your homework night to night, okay, at least give your homework an attempt. The next day, things can start to get confusing again. So it's very imperative, even if you're struggling a little bit with your homework, that you at least give it an attempt so that you can get your questions answered the next day. Because one thing leads to the other for the rest of this course. So one day's work is going to lead directly into the next day. Now, before we actually dive into this, I just wanted to remind you of where we are. Algebra is divided into what? 3 branches, just very quickly. I explained this earlier this year. This is expressions, what? Equations and functions. Okay, so algebra is divided into 3 branches: the expressions, the equations, and the functions. And we're going to be traveling now this direction through the course, starting with what? Expression. I gave you guys 10 parent functions as you guys had to memorize their shapes. The ultimate goal of this class is to learn what? Everything about functions. And for the first 6 weeks, we've been investigating a lot of concepts about functions, like domain and range. You have seen these terms a lot. Why? So that you could get some fundamental concepts of functions before we actually get there. But now we have to learn every expression, meaning we have to learn what the polynomial, how to deal with polynomial expressions, how to deal with logarithmic expressions, and how to deal with rational expressions. After we deal with expressions, we will learn how to solve the equations. Okay, so expressions will lead us into the realm of equations, and equations will lead us into the realm of functions. Now, the ultimate goal of this class, again, is to arrive at what? An understanding of what a function is. And in fact, all 10 of the parent functions that were given on your parent functions list that you've already memorized the shapes of. So this is the ultimate goal of the class. Now, before we get, let's just go ahead and diagram very quickly. What are we looking at today? Polynomial expressions. I want you to draw this box. Okay, and we're going to call this box, this marker's running out. Let me grab another one. Okay, in this box represents rational expressions. Okay, rational expressions. And within the rational expressions, we have polynomial expressions. Okay? Now, so the polynomial expressions are what are written on the board. Polynomial expressions are what we're studying. But within the realm of rational expressions, we have polynomial expressions. So before we do anything, I want you to see this. Is every rational expression a polynomial expression? The answer is no. But is every polynomial expression a rational expression? Yes. If you don't understand this diagram, let me draw this diagram here. If I give you a box that represents all mammals, okay, how do we read these diagrams? This box represents all mammals on the earth. Cows, dogs, okay? Any mammal you can think of. Whales, okay? Within the set of mammals, we have the set of dogs. Now, my question is every mammal a dog? No. Okay? Are cows in the set of dogs? No. But are cows in the set of mammals? Yes. So is every mammal a dog? No. But if I asked you, is every dog a mammal? Yes, because dogs are within the set of mammals. So looking over here, Question, is every rational expression a polynomial? No. But is every polynomial expression a rational expression? Yes. So let's go ahead and define really quickly, or at least show you what are we talking about. Okay, so the key here to understanding the topics that are going to be discussed today is, first, you must understand the difference between multiplication rules and addition rules. In fact, your success this entire 6 weeks is going to be depending on, do you understand the difference between multiplication rules and addition rules? So you have to be able to clarify the difference. Now, first, I want you to think of multiplication. Multiplication is glue. Addition breaks things apart or separates things. So multiplication glues things together, and addition breaks things apart. So if I write this, 3xy, do you see 3 times x times y? 3 times x times y, we think of this as what? Multiplication is what? Multiplication is glue. So this is glued together as one thing. You are not seeing 3 things, you are seeing one thing. We call this a monomial. Okay, mono means one. This is called a monomial, meaning one term or one unit y. It's glued together by multiplication. You should see 3 times x times y is not 3 things, but one thing. This is one term, or we say one product, called a monomial. If I write 3xy plus 2z, now we see addition coming in. So I want you to see, do you see a product and a product? Okay, 2 products on the board, 3xy and 2z. You have 2 products on the board separated by what? Addition. Okay, so remember, addition breaks things apart. Think of this as 2 separate properties. This is a property, no trespassing. And this is a property, no trespassing. What is separating the properties? A fence. The addition is the fence that separates the properties. And you cannot go, someone on this property cannot go on this property. This is the addition is like a fence that breaks 2 properties apart. Okay, so we have a product and a product separated by addition. We call this a binomial. 2 terms. Okay, and 3xy plus 2z minus 7. Okay, we have how many products? We have a product, and a product. You say, wait a minute, 7 is not a product. Yes, it is. 7 is a product of 7 and 1. Okay, so 7 is also a product. So we have 3 products on the board. We call this what? Trinomial. All right? 3 products separated by what? Addition. So 1 product, 2 products separated by addition, and 3 products separated by addition. Monomial, binomial, trinomial. All of these are called what? All of these are called polynomials. Poly means many. Okay, many terms if you want to think of it this way. Polynomials. So all of these are polynomials. Now, I'm going to ask you to name these things on quizzes. We call this what? Monomial. We call this binomial. We call this trinomial. I don't name it polynomial. If I say, what is the name of this? Do not call it a polynomial. Be more specific. Polynomial, out of a 2-point question, polynomial loses a point. But trinomial is correct because it's more specific. Be as specific as possible. So this is a trinomial. However, if you have more than 3 terms, 3xy plus 2z minus 7 plus 8a, if you have how many products? 1, 2, 3, 4 products. If you have more than 3 products, I want you to just call this a polynomial. That is as specific as you can be. So we only name up to 3 terms. Okay, so this is a polynomial. I can't spell when I'm talking fast. Okay, polynomial. So 1 term, monomial. 2 terms, binomial. 3 terms, trinomial. Any more than 3 terms, the most specific that you're going to be in this class is polynomial. Now, what is a rational expression? Okay, so we're going to define rational expression. Rational expression, ratio, or rational expression is a ratio of polynomials. So we're looking at a polynomial. Polynomial divided by what? Polynomial. Okay, all right, so polynomial divided by polynomial. Rational expression is a ratio of 2 polynomials. So my question is 3x plus 2z over 4x, is 3x plus 2z over 4x a rational expression? Yes, it is. Why? Because on top we have what? 2 products separated by addition called binomial. On top we have a binomial. On the bottom we have what? Monomial. So we have binomial divided by monomial, or polynomial divided by polynomial. This is what? This is a rational expression. So you will name this on a quiz, rational expression. Now, So the name of this thing is rational expression. Now question, what if I write 3x plus 2z, or let me just say this here. What about 3xy? 3xy, written here. Is 3xy a rational expression? Yes. What did I say? Every polynomial is what? A rational expression. Look, 3xy is what? A rational expression because it is 3xy over what? 1. On top we have what? A monomial. And on the bottom we have what? A monomial. 1 is considered to be a monomial, one product. Okay, so we have a monomial divided by monomial. Is this a rational expression? Yes. But if you name this a rational expression on a quiz, you lose 2 points. If you call it a polynomial, you lose 1 point. If you call it a monomial, you get full credit. Why? Because you need to be as specific as possible. Look, if we write 3xy, okay, my question is 3xy a rational expression? Yes. Be more specific. Is 3xy a polynomial? Yes, it's in the realm of polynomials. It's in this group. But be even more specific. Within the realm of polynomials, what do we have? We have 3 divisions. In the realm of 4 divisions, really. We have what? We have mono, we have binomial, and we have trinomial, and we have polynomial. Okay, so actually 4 divisions in the realm of polynomials. So there are 4 divisions. Be as specific as possible. So 3xy, okay, you're not just going to call this a rational expression. Too general. Be more specific. Is it a polynomial? Yes. Be more specific than that. It is one term, so we call this what? Monomial. All right, now, what if I write here? What if I write 3xy over 2? Question, is this a rational expression? Yes. But can you be more specific? Yes. Okay, so you're not going to call this rational expression on a quiz. You will call this monomial. Why are you calling it a monomial when there's a denominator of 2? The rule is this. When do we call it a rational expression? That's what we have to establish. We name it rational expression when there is a variable in the denominator. When there's a variable in the denominator, we name it rational expression. So, for instance, 3xy over 2z. Is there a variable in the denominator? Yes, there is a z in the denominator. So we call this what? We call this rational expression. Okay? That's as specific as we can be. However, what if there is no variable in the denominator? If there is no variable in the denominator, we call this, or we name it by the numerator, we name it a monomial, because the numerator is a monomial. Why? Let me show you. Because this is equal to 3 over 2 xy. We can write 3xy over 2 as 3 halves, or 1.5 xy, and you see the monomial. Let me show you this. Question. Is 3xy plus 2z over 4x plus over 4x here? 3x over 2z, 3x plus 2z over 4x. Be as specific as possible and name this. What is this called? Well, since there is a variable in the denominator, we call this what? We call this what? Rational expression. That's as specific as you can be. Why? Because there is a variable in the denominator. However, if I write 3x plus 2z over 4, be more specific. Since there's no variable in the denominator, we call this what? We call it a binomial. We name it by the numerator. Okay, so this is a binomial. As specific as you can be. And if you have more than 4 terms, so for instance, 3x plus 2y plus 5z plus 7 over 4, there is no variable in the denominator. Okay, so you're going to name this by the numerator. Since the numerator has 1, 2, 3, 4 products, you will call this a polynomial. Okay, so hopefully that doesn't confuse. We're going to talk more about nomenclature, but it's very important that you know what you're looking at. All right, so next. All right, let's get into the lesson. Very simple. This stuff's actually pretty quick and easy, but I need you guys to know what you're looking at before we start. Okay, so we're looking at here. Today, what are we doing? Well, let me erase all this so we can fit this. Okay, today we're looking at, I should say, what are we doing? Well, this word, simplify. What does simplify mean? Simplify means to what? Add, subtract, multiply, and divide. I ask students all the time, what does simplify mean? Every year. And they always say, to make simple. No. Simplify does not mean to make simple. In fact, I'm going to show you examples as the year goes on. Simplify does not mean to make simple. I'm going to show you things that we simplify that start out very small, and when we get done, they're complicated. So simplify can actually mean to complicate. Okay, simplify does not mean to make simple. Okay, we need to learn, what does the word simplify mean? I wish someone would have told me this when I was in high school. Simplify, factor. You know, I had to try to figure out, what do these words mean? Simplify, factor, solve. Okay, we need to know what we're doing depending on the direction. Simplify, what does it mean? It finally hit me. Simplify just means to what? Add, subtract, multiply, and divide. Now, today we're going to start with just multiplication and division. Multiplication and division of what? Multiplication and division of polynomial expressions. Now, question, are polynomial expressions also rational expressions? Yes, so technically I could have named this lesson Simplifying Rational Expressions. Okay, so we're dealing with polynomials and what else? Polynomials and the bigger group is called rational expressions. So that's something to note. So we're really doing both. Okay, so simplifying polynomial and rational expressions. We're going to start with what? Multiplication and division. We call multiplication and division laws of what? Laws of exponents. Okay, so laws of exponents are what type of rules? Laws of exponents are multiplication rules. And if I have not said it already, or made it clear, I did already mention it, made it clear, you must understand the difference between what? Multiplication rules and what? Addition rules. You must be able to keep these straight. If I say something is a multiplication rule, what does it also apply to? Multiplication rules also apply to division, because multiplication and division are the same thing. If I say that something is an addition rule, does it also apply to subtraction? Yes. Addition rules are the same as subtraction rules. So multiplication, division, addition, subtraction, we will always look at these separately. And then when we start putting it together, things start to get confusing. So you guys have to keep the rules straight. Now, starting with this, x squared multiplied by x to the third. What are we looking at here? Okay, so we have 2 x's multiplied by 3 more x's. What is this? X times what? X times x times x. 2 x's multiplied by 3 more x's is how many x's multiplied together? That's 5. What are we doing with the exponents? We are adding the exponents. Question, are we adding? No. Are we adding? No. What are we doing today? We are what? We are multiplying. So when I say add the exponents, are we adding today? No. What are we doing? We are counting. This is what I'm trying to get at. We are counting the number of times in which we did what? Multiplied. Look, x squared times x to the third. This is what? 2 x's multiplied by 3 more x's. Do you see any addition on the board? No. You see a string of multiplication. So what are we doing today? We are multiplying. When I say with my mouth, add the exponents, or what do you do with the exponents? You add. Are we truly adding? No. We are counting the number of times in which we did what? We're counting the number of times in which we multiplied. So it's very important that you see today that we are not adding, we are multiplying. We are counting the number of times in which we multiplied. 2 x's times 3 more x's gives a total of how many x's? 5 x's multiplied together. So x squared times x cubed is x to the 5th. When the bases match, I say with my mouth, we add the exponents, but you understand that we are not truly adding, we are counting the number of times in which we did what? Multiplied. Now, so these are all multiplication rules, laws of exponents. Next. Okay, so if we multiply, we add the exponents. Again, we're counting the number of times we multiply. If we multiply, we add the exponents. What happens if we divide? If we divide x to the 5th divided by x squared, what do we do with the exponents? We subtract. 5 minus 2 is what? 3. So we get x cubed. So subtract the exponents when you divide. Now, what if I say x squared to the 3rd power? What do we do with the exponents? Well, we multiply the exponents. We get what? X to the 6th. So power of power, what do? Power of power, we multiply. Let me show you why. What does x squared to the 3rd power mean? X squared to the 3rd power means what? X squared times x squared times x squared. Something to the 3rd power means do it 3 times. So x squared times x squared times x squared, what do we have? X times what? X times x times what? X times x. How many x's are multiplied together? 2, 4, 6. Do you want to add 2 3 times, or is it faster to multiply? It's faster to multiply. So when we have power of power, we multiply the exponents. Okay, so we have addition of exponents, subtraction of exponents, multiplication of exponents. What's missing? What's missing? Division of exponents is missing. And what is division of exponents? Division of exponents will be covered later, and it is referred to fancy division. Fancy division. You learned this as square root. In elementary school, you learned that divide was 6 divided by 2. This is old school division. 6 divided by 2 gives 3. But division of exponents, this is high school division or advanced division, or here, fancy division. This is a fancy division symbol. We call it square root. Square root of 16 is what? 4. What are we dividing? What are we dividing? What are we dividing? We're dividing what? We're dividing exponents. We're going to talk about this later. So square root is fancy division. It means the division of the exponent. This is not covered yet. Today we are adding, subtracting, and multiplying exponents. So let's look at some examples. I've given you a handout sheet. Let's go ahead and knock these examples out. They're really fast and really easy. Okay, so we're looking at number 1, b to the 4th, b cubed. b to the 4th times b to the 3rd. Now, when I put these problems up, I hope that you pause the video. Actually, I'll write them on the board. I want you to pause the video, and I want you to attempt to solve each one of these without looking. You know how to do this. C to the 5th, c squared, c squared. So c to the 5th times c squared times c squared. Number 3, knock these out. Okay, so number 3 is a to the negative 4th, a to the negative 3rd. And number 4 is x to the 5th, x to the negative 4x. X to the 5th times x to the negative 4th times x. So pause the video and attempt these 4 problems. Okay, now, what are we doing with the exponents here? When the bases match, we have 4 b's multiplied by 3 more b's, we get what? B to the 7th. Question, are we adding exponents? Yes, we're adding exponents, but are we adding in general? No. What are we doing today? We are multiplying. Adding exponents means we are counting the number of times in which we multiply. We have b times b times b times b multiplied by b times b times b. So we have 4 b's multiplied by 3 more b's is a total of how many b's multiplied together? 7. Okay, so adding the exponents is a matter of counting the number of times in which we did what? Counting the number of times in which we multiplied. I like to say it like this. What is 5 c's times 2 more c's times 2 more c's? Well, that's 5 c's plus 2 c's plus 2 c's, a total of how many c's multiplied together? Well, that's 9 c's. 5 plus 2 is 7 plus 2 is 9. So we're adding the exponents here. Again, same thing. Add the exponents. Negative 4 plus negative 3 gives what? A to the negative 7. Now, this is not an acceptable final answer. If you stop here, this is wrong. You lose points. Okay, the same people that got together and decided that 0 factorial is equal to 1 are the same people that got together and decided to make rules for simplify. So simplify has a lot of hidden rules that you guys need to know. So simplify, what are some of the rules? Well, the first rule that we're going to add, we're going to have lots of rules. The first rule for simplify, these are rules. Simplify rules. Okay, so for rules for simplification, the first rule is that you cannot, no negative exponents in the final answer. No negative exponents in the final answer. Okay, so the first rule is no negative exponents in the final answer. Look at this. Can we have a to the negative 7th as the final answer? No. Why? Because it has a negative exponent. Now today in this video, I'm just going to quickly show you what to do with a negative exponent. In the next video, I will show you what it means. So when we have this here, x to the negative 2 power. What does x to the negative 2? Today I want you to think negative exponents mean move from numerator to denominator or move from denominator to numerator. Once you move it, you change the sign of the exponent. So where is this? This is x to the negative 2 over what? 1. Okay, so we're going to take x to the negative 2 and move it where? To the bottom. X to the negative 2 moves to the bottom, becomes what? It becomes x to the positive 2 on the bottom, and what's left on top? Nothing. Now, when I say nothing, do I mean a 0? No. When I say nothing right now, I mean a 1. Okay, so it moves to the bottom. What's left on top? A 1 is left on top, and it changes sign. So x to the negative 2 moves to the bottom, becomes x to the positive 2. Here, let's look at this. 1 over x to the negative 2. Also, negative exponents mean move from bottom to top. Okay, so we can move it from the bottom to the top and change the sign of the exponent. So x to the negative 2 moves to the top, becomes x to the positive 2. X to the positive 2 over 1. And do we write over 1? No, so we just get x squared. Question, what is 3 to the negative 2? I ask students this. Is this a negative value? No, this is not a negative value. This is a positive value. 3 to the negative 2 does not refer to negative number. It refers to moving the position of the number within the numerator and denominator. We move it where? We move it to the bottom. We get 1 over 3 squared. Then the exponent changes from negative to positive. So after you move it, the exponent changes sign. So negative to positive, we get 1 over 3 squared, which is 1/9. What type of value is 3 to the negative 2? It's a positive value. Question, what is 3 to the negative 1 power? 3 to the negative 1 power, move it to the bottom, what do we get? We get 1 over 3. So going back to this, we cannot have negative exponents in our final answer. So what are we going to do here? Well, a to the negative 7th becomes what? 1 over, the a to the negative 7th moves where? To the bottom and becomes a to the positive 7. Okay, so that's it. That's it. This is the final answer because we have made the negative exponent positive by moving the whole unit to the bottom. Now here, same thing. Bases match, add your exponents. 5 plus negative 4 gives what? 5 plus negative 4 gives 1. And what is the unwritten exponent here? If an exponent is unwritten, what is it? It's a 1. Do we write the 1? No. We understand this exponent to be 1. 5 plus negative 4 is 1 plus 1 is what? 2. So we get x squared. All right, now, next set of problems. Again, I want you to practice these without my help. 2x quantity squared, 4y quantity squared. Okay, so we're looking at number 5 on the sheet. 2x quantity squared multiplied by 4y quantity squared. Now, what do we have on the outside? We have an exponent on the outside of parentheses. Now, I want to show you this. So, quantity 2x squared. Question, do exponents distribute over multiplication? Yes. Now, I'm going to say this a lot. Distribute. Do exponents distribute over multiplication? Yes, they do. Exponents distribute over multiplication. But is this distributive property? No. So I don't want you to get confused when we get into distributive property. No, this is not distributive property. In fact, it's not even proper for me to say this. But I'm going to use this terminology to help. Okay, so exponents distribute over what? Distribute over the multiplication is how I'm going to say it. Why? So we end up with what? We end up with 2 squared what? X squared. So we square the 2, we square the x. The exponent affects everything inside parentheses. Now, why? Well, let's look. 2x quantity squared means what? It means 2x multiplied by 2x. Now, we do 2 times 2 and get what? 2 times 2 is 2 squared, and x times x is x squared, or we just get what? We get 4x squared. So, question, do we square everything inside parentheses? Yes. Does the exponent affect the 2? Yes. Does the exponent affect the x? Yes. So we end up with what? 2 squared. Square the 2, we get what? 2 times 2 is 4. Square the x, we get x squared. Now, put parentheses around this, square the 4. Do exponents distribute over multiplication? Yes, they do. Square the 4, we get what? 16. Square the y, we get y squared. And now just multiply this together. Or glue it together. Remember, multiplication is like glue. This means glue things together. 4 times 16 is what? 64. And just glue the x squared, y squared together. So we have x squared, y squared. And always put your variables, for now, in alphabetical order. Put x before y, put y before z, put a before b, and b before c. All right, so put your variables in alphabetical order. Now, next problem, number 6. Number 6 is negative 2gh. Negative 2gh multiplied by g cubed h to the 5th. G to the 3rd, h to the 5th. Now, do we have any exponents on the outside of parentheses? No. Okay, so we're just simply adding exponents here. Negative 2 times 1 is negative 2. 1g times 3 more g's. We are adding our exponents. We get g to the what? 4th. 1h times 5 more h's is h to the what? H to the 6th. Okay, so adding exponents again. These are assumed to be 1. 1 plus 5 is 6. All right, so this is our final answer. Next, number 7. Number 7, all of these are pretty easy. 10x squared y cubed. Number 7, 10x squared y to the 3rd multiplied by 10x y to the 8th, I believe. Multiplied by 10x y to the 8th. Okay, good. Now, so notice, we have parentheses. Are there exponents on the outside of parentheses? No. So we just simply multiply. 10 times 10 gives what? 100. X squared times x, 2x's multiplied by one more x gives what? X to the third. And y to the third times y to the 8. 3y's multiplied by 8 more y's. We are adding the exponents gives what? Y to the 11th. So we are done. Number 8. Number 8. Okay, so now we're getting into canceling. 24wz to the 7th. 24wz to the 7th over 3 w to the third z to the 5th, I believe, if I'm reading that right. W to the third z to the 5th. W to the third z to the 5th. Now I'm going to write this out one time for you so that you can see it. And then I want you to see the trick. Okay, so we're looking at, first let's cancel our numbers. First cancel the numbers. So 3 cancels with 24, divide them each by the same thing. They both are divisible by 3. 3 divided by 3 is what? 3 divided by 3 is 1. Do we write the 1? No. So I don't want you guys writing 1s. 1s are redundant. 24 divided by 3 is 8. So we end up with what? We end up with 8w z to the 7th over w to the 3rd z to the 5th. Notice I did not write the 1. Now, I want you to see this. We have 8 on top. How many w's? We have 1 w. And how many z's? We have 7. So 7 z's. Z times z times z times z times z times z times z. 1, 2, 3, 4, 5, 6 times z. So there's 7 z's. And on the bottom we have 3 w's. That's www dot, no, I'm just joking, times z times z times z times z times z. Okay, so the question is, can we cancel? Yes. I want you to see it visually. 1w cancels with 1w, leaving how many w's? Okay, so if we had 3 on the bottom, 1w with 1w cancels, leaving what? 2 w's where? On the bottom. Can you see it here? If we cancel 1w with 3 w's, how many are left? It's a concept of subtraction. Remember, when we divide, we subtract exponents. 5 minus 2 gives 3. So notice, 1w cancels with 3 w's. What does 3 subtract the exponent 1? 3 subtract 1 gives 2. So where are the 2 w's left over? We subtract the exponents. Where are they left over? Well, they're left over on the bottom. Why? Because there are more w's on the bottom. So we have on the bottom w squared. Now, can you see this? There are 5 z's on the bottom. There are 7 z's on top. If we cancel 5 z's with 5 z's, how many z's are left? Well, there are 2 z's left. Do you see subtraction? Take the exponent 7, subtract 5. What is this? 7 subtract 5 leaves 2. So if we cancel 5 z's with 7 z's, we're left with 2 z's. Where? On top, because there are more z's on top. So our final answer is 8z what? Squared over w squared. This is our final answer. So canceling is key here. Next problem, I'm just going to look. I have my computer up here with the problems on it. Okay, our next problem is negative 6a to the 4th, negative 6a to the 4th, b c to the 8th, over 36 a to the 7th, b squared times c. Now, this is question number 9. Question number 9. And we're looking at canceling, but I want you guys to see something here. Negative 6. I need you guys to see negative 6 as 2 separate entities. We have a negative and a 6. You cannot see negative 6 as one thing. For this part of the course, you need to see negative 6 as 2 different things. It is negative 1 multiplied by 6. We don't write the 1, we just say negative times 6 is what? Negative 6. Do you see that negative is separate from the 6? Yes. Okay, so the negative and the 6 are separate. Now, we're going to cancel, dividing both of these numbers, 6 and 36. Now, I'm not talking about the negative. The negative is separate. Canceling 6 with 36. We divide them each by the same thing. What divides both? 6. So 6 divided by 6 is 1. Do we write the 1? No. It's redundant to write the 1s. 36 divided by 6 is 6. So what are we left with here? Let's write our answer. We're left with, on top, we're left with a negative. And then the bottom, we're left with a 6. Now let's cancel our variables. Hopefully from the previous example, 4 A's cancel with 7 A's, leaving how many A's? We're subtracting. 7 minus 4 is 3. So we're left with 3 A's, but where are they? They're on the bottom because we had more A's on the bottom. 1B canceled with 2 B's, leaving how many B's? Well, 1B, where? On the bottom. 1C cancels with 8 C's, leaving how many C's? Hopefully you say 7 C's on top. So we're left with what? Negative C to the 7th over, on the bottom we have 6A to the 3rd B. So our final answer is negative C to the 7th over 6A cubed B. And one more example and we'll be done. Number 10, I want you to attempt this on your own. Pause the video, attempt this on your own, and then we'll look at it. So number 10 is negative 10 pt to the 4th r over negative 5 p to the 3rd t squared times r. Okay, so we're looking at here, what do we have here? 2 negatives. Remember, the negatives are separate from the numbers. So we see negative 10 as 2 things, we see negative 5 as 2 things. What happens with the 2 negatives? The 2 negatives cancel and become positive. Now the 5 and the 10. What divides both? Well, 5 divides both. 5 divided by 5 is 1. Do we write the 1? No. Okay? 10 divided by 5 is 2. Now cancel. 1p cancels with 3 p's, leaving how many p's? It leaves p squared. It leaves 2 p's on the bottom because there were more p's on the bottom. 2 t's cancel with 4 t's, leaving how many t's? Hopefully you say t squared. Where? 2 t's on top. And lastly, the r's cancel. What's left? What's left? Nothing. Well, what does nothing represent? If everything cancels out, what's left? A 1 and a 1. Again, do we write the 1's? No. This is redundant. So when I say nothing right now, nothing refers to the number 1, not 0. So we do not get zeros. What do we get? When everything cancels out, we get 1's that we don't write. We get the number 1 and the number 1. We don't write these. And our final answer is what? 2t squared over what? P squared. All right, that concludes this video. Good luck on your homework, guys.